Take a look at these data points. You probably have a few questions about them already. Where are they going? Where do they come from? What do they represent? Well, the last one's up to our imagination, but even without a definitive answer, we can make some pretty useful predictions about the former two. Here's a line of best fit, a parabola of best fit, and a logarithmic curve of best fit. The problem that all of these models have is that they are a bit inaccurate, not always lining up with the actual numbers. How can we fix this? Well, instead of creating a curve with a fixed shape that is as close to the data points as we can get, we can construct one from scratch, which is guaranteed to string through all of them. Now, we want this curve to be continuous, so all you smartasses proposing the null gambit can go home. I don't know, you likely don't have one if you suggest something that lame. Anyways, we want all of these points on a new curve as a function of the independent variable equal to that of our dataset. In other words, we want this system of equations. I'm going to use a polynomial for this, but I'm sure there are other working templates. We have our corresponding x and y values in this table already, and we can do some elementary row operations to find the coefficients. And we're done. Now, in real life, all of these numbers and graphs and stuff would mean something, and the only reason anyone would ever bother to, say, extrapolate it using some kind of best fit curve would be to make some conclusion about the data that isn't directly observed. Our curve here is not one of them. It exists for the lone purpose of fitting specifically this tiny set of information. The nature of polynomials means that their tails will tend towards negative or positive infinity. The more academic term for this property is end behavior. This already rules out their utility for any oscillating relationships. Furthermore, there's an abundance of linear and even quadratic relationships in nature, but using this strategy for any dense dataset will produce some big degree polynomial, which is unhelpful because just fucking look at it!